First of all, I just want to say how proud I am of how hard you guys worked for the first chapter test. Really impressed with the thinking I saw, really impressed with your ability to work with one another, and to put forth your best effort. Okay, keep it up through the rest of the year. We're going to have an awesome year. Our new chapter is going to be on inequalities. Now, inequalities is going to have a lot of components the same as chapter 3 on equations. Okay, this will give you a chance to build some skills if you didn't quite catch everything in the equations chapter, or really just to review and refresh working with inequalities. A reminder what an inequality is. An inequality is two expressions that are separated by a less than, a greater than, a less than or equal to, or a greater than or equal to. Okay, so when we're looking at an inequality, here is an example of an inequality. When I look at this inequality right here, it says x is greater than 2. Okay, well think about what numbers are greater than 2. Okay, there'd be 3 and 4 and 5 and 6 and 7 and 8. Okay, how many solutions are there to that? A lot, right? There are an infinite number of things that are larger than 2. Okay, not only whole numbers. We're talking 2.00001 is also greater than 2. So if I want to state the solution to x is greater than 2, okay, I need to use a number line so I can show all of the solutions. So when I look at this in words, this would say this is all real numbers that are greater than 2. Okay, so then when I go to my graph, okay, I want to think about what's greater than 2. Okay, well obviously 3 and 4 and 5 and 6, but what about 2? Is 2 greater than 2? And the answer is no. So if I'm making a graph and I'm shading all of the things that are greater than 2, I don't actually want to shade 2. I want to shade as close to 2 as I can, right? 2.000000001 is a solution, but 2 is not, which is why I'm going to use an open dot. So to do this first one, all real numbers greater than 2, I put an open dot on the 2 and then shade everything greater. Okay, some people draw it right on the line, other people use an arrow like that. That represents everything that's greater than 2. Notice I put an arrow on the end to show that it keeps going forever. The next one says all real numbers less than or equal to -3. In this case, -3 is a solution. Since -3 is a solution, we'll shade in the dot. We'll use a closed dot, okay, on the -3. Closed dot on the -3, this time I want everything less than that. So I'm talking about -4, -5, and everything to the left. Okay, this last one has the variable on the right side. There's a couple of things you can do. First of all, some people like to flip those around so the variable is on the left side. If I read that, I need to read what the x is. I can see here that the x is greater than or equal to the -1. Or if I want to flip it around, make sure that the inequality still points the same way, right? Look at that. I flip it around. I've got x greater than or equal to -1. So, open or close dot. The answer would be closed because we want to include -1 in our solution step. So I'm going to fill that in. Want everything that's great. Solving equations and solving inequalities is virtually the same thing. However, there is one major difference. A refresher, I'm sure you did this in pre-algebra, but just a reminder that the only thing that is different when we're solving inequalities is that we are going to reverse the inequality when we multiply or divide by a negative. Now why? Why are we reversing the inequality when we multiply or divide by a negative? Let's look at an example. Okay, I can look at an example right here, and I'm going to say that 3 is less than 5. Okay, I'm sure everyone agrees with me that 3 is less than 5. Now let's pick a negative number to multiply by. Let's say we're going to take both sides of the inequality times a -2. Okay? Well, what happens? When I take -2 times 3, I get -6. When I take -2 times 5, I get -10. We can see here that -6 is not less than -10. -6 is actually greater than -10. Okay, so what we need to do when we multiply or divide by that negative is we reverse the inequality. Right? We're going to flip the inequality around. Okay? Doesn't affect addition and subtraction, only affects multiplication and division. So let's remember that. Let's take a look at a couple quick examples of solving inequalities. if I look at example 1 right here, following the same steps to isolate the variable, I want to get the x all by itself. So I'm going to go ahead and get rid of the 3, subtracting 3 off both sides. And that leaves me with negative 2x less than or equal to 20. Okay? My second step would be to divide by the negative 2. I am remembering that when I divide by that negative, I'm going to reverse the inequality. So this is going to become x is greater than or equal to negative 10. Now things we want to know. When I graph this, will I use an open or a closed dot? Answer's closed because I want to include the negative 10. Okay, and which way will I shade? So I'm going to make my graph here. We're going to have negative 10. I want to go a couple on each side. So negative 9, negative 8, negative 11, negative 12. Okay, we said we're going to use a closed dot. And we want everything that is greater. So we're going to be going to the right of negative 10. On my second example, we're solving for y. Let's isolate the y. We will add 3 to both sides. That gives me negative 7 greater than negative y. If I want to get rid of that negative, reminder that means I'm going to divide both sides by a negative 1. When I divide by the negative 1, I remember to reverse the inequality. So this becomes 7 less than y. If I look at 7 less than y, let's rewrite it so the variable's on the left side. That would be the same as y is greater than 7. So when I make my solution here, I go to my graph. Okay? I can put 0 in here if I want, but let's put 7 in the middle, and let's just get a couple of numbers on each side. Okay, we said we were going to use an open dot because we don't want to include the 7, and we want everything greater than 7. Okay, tomorrow when we get to class, we're going to be doing all sorts of problems with inequalities. Please remember 2 things. Should I use an open or closed dot? What way should I shade? Also, please remember when solving that if you're multiplying or dividing by a negative, we need to reverse that inequality. Okay, see you tomorrow. Let's be ready for class.